Welcome back to Tech Under 20 Ventures. This is case 1, week 2, helping understand post-COVID businesses. If you haven't been to the week 1 workshop, that's okay. We have a recording of it up on YouTube, and timestamps for it will be coming soon. I'll work to get them up by this evening. Essentially, timestamps are useful because it lets you kind of segment the workshop into more digestible pieces. It is a 1-hour workshop, and a 1-hour workshop is what it's going to be today as well. So without further ado, let's move on to the agenda for today. So today's agenda will be, first, a group activity. A group activity that we are trying out with Zoom breakout rooms. Second, we're going to do pagination in web scraping. That's moving through different pages on the same kind of website. Then we're going to talk about navigating HTML tables. Quite useful for most of everything, but HTML tables kind of bring it all together. And finally, we're going to talk a little bit about packaging and exporting data. That one's going to be quite short and sweet. And then we're going to move on to questions and answers. Oh yeah, and also a little bit of application. So let's see, we got first, group activity. For this activity, you will be put in Zoom breakout rooms with 3 to 4 others and given a Google Colab document with a challenge. It is recommended that group members share their screen as Google Colab does not update changes in real time. Remember to make good use of inspect element. What do I mean by that? Well, hold on. If we go to any Wikipedia page once again, how do we know what HTML tag something is? How do we know what part of the web page, what part of the HTML is responsible for any part of the web page? Well, what you have to do is you have to right click whatever you want to check. So for example, I want to check what this title is, what kind of tags this title is made out of. So I right click it, click inspect, and there it is right there. It's a big old H1 tag with an ID of first heading and class first heading. What if I am now here, but I want to know even more about some other tag. There's this really, really handy tool at the top here with this little arrow. Click it so it's blue, and start basically hovering over stuff. And when you hover over stuff, you can see that on the right, the HTML is being highlighted. The part that's relevant is being highlighted. So say I wanted to see what this 1950 subtitle is made of. You can see it's a span tag with a class and an ID. So that's what you're going to be doing today. I decided to base the activities on this Wikipedia page, the COVID-19 pandemic. So every group is going to have something different to scrape off of this web page with some starter code and a little bit of instruction. Some of them are harder than the others. It's meant to be that way, but a lot of all the easier ones have extra challenge components onto them. I believe that everyone in this call right now is capable of working together and getting something done. And afterwards, we'll talk about it for a little bit before moving on to the lesson segment of this workshop. So without further ado, Sam, could you help us? Could you set up the breakout rooms?
Yep, sounds good. So Timur, we have 27 minus, I think, about 2 people, so 25 people. Can we do 5 breakout rooms?
Yes.
Alrighty, sounds good.
Essentially, they were trying to copy this image from the COVID-19 pandemic Wikipedia page. How did you guys find that? Was it easy? Was it hard?
For some it was easy. For some it was hard. I don't think it was too difficult. All you really had to do was go to the image, click inspect, and then you'd look for the image tag, right? And then you'd find the alt name and then you'd paste it in.
I see. Any other comments from group 1? No? All right. What about group 2? What happened? Right. What happened to group 2?
We basically solved the first challenge about so I'll share my screen too. Oh,
cool.
Yeah, Vedant. Sorry, Timur, whoever's sharing the screen. I'd like to share my screen. Okay, good. I'll do it right now. There you go. Yeah. So this was our challenge. So we have to scrape all the subtitles from the COVID-19 wiki page. And so basically, I can go over the solution a little bit. So we went to the page, and you can just basically inspect element for any of these titles or subtitles. So in this case, let's just do background. And over here, we realized that these subtitles are enclosed in these H2 and H3 tags. So H2 tags and H3 tags are just HTML tags that represent like a title or something. And we looked into those tags, and then we see these extra tags called span tags. But that wasn't the main thing we were looking for. We also noticed that the span tags, they all shared this class name called MW/headline. So then going back to the collab, we decided to scrape the wiki using this class name called NW/headline. And so we used the function in the Beautiful Soup package to scrape all the elements with that class name. So using this function, soup.findAll. And then finally, we had to extract all of the text because the result only returns the text, but with the tag names as well. So then we had to extract the text as well using this function, r.getText inside a for loop. And then once you print that out, you can get all of the subtitles like this.
And you copy pasted from week 1, part 2? Last week's workshop?
Yeah, basically, copy paste.
Awesome. What about group 3?
All right, I'll stop sharing.
Group 3, someone from group 3. How was your experience?
Well, never got around to like finishing it, but I can share my screen and show what we did do.
Cool.
Yeah.
That sounds good.
Okay. So we were supposed to scrape this website and find the table of contents.
Okay.
So we went on here and we clicked inspect, and then we found the table of contents, and then we found the if anybody else from group 3 wanted to cut in, that'd be cool too. But yeah, so we found like the ID and the class from there, and then we put that into our thing. 1 second, sorry. So we had our code here, put our like URL, and then down here is our class name and our ID name. And then
we also had the tag name too. We also found the tag name by inspecting that element too, which was UL as you showed.
Yes, exactly. I do not know how we found the tag name exactly, but it was UL. And then we ran that. And when we ran that, we got all this stuff, just a bunch of solid text. And then this is, I think I altered the original, I altered the original code a little bit that is on your thing, but that you made. But so this one prints it out like for each tag in the list, and it like is supposed to strip it of its white space a little bit. But here it's like the table of contents starts, and then it goes all the way down. So yeah.
Awesome. Sounds good. You guys did great. You guys did great. Awesome solution. What about group 4?
All right. So I should share my screen now, right? Let's do that. Can you all see this?
Yep.
All right. So turns out we didn't read the instructions, right? Because we wrote our own code. But our goal was to find all the titles.
Your COVID page? Can you guys still hear me?
Yeah. You cut out for a little bit.
Hello?
You cut out for a little bit.
We gotta turn it down. Hello?
Hello. We can hear you.
What the heck?
We can hear you.
Hello?
He probably can't hear us.
This is weird.
Technology struggles.
He probably can't hear us.
That's not good.
Who's talking right now?
Pranav.
Enough.
Hello, Pranav. Oh, no.
All right, okay. I guess I
there we
can't
go.
hear you guys, but you can hear me. So that works out. Our goal was to find all the titles from this Wikipedia COVID page. So what we did is, first we had this. It got everything, all the HTML content. Then we created a variable for tag name because we wanted to find that. And then we used find all to like get all the A tags in like this entire HTML content of the Wikipedia page. Then we just looped through every single result and checked if that result was equal to none because we wanted to filter out all these nones right here in the titles. So we just checked if the result was equal to none, and if it was, then, or if it wasn't equal to none, and if it wasn't equal to none, we would add it to the final list, this empty list right here, and then print out the final list.
Awesome. Quite involved indeed. I will tell you that these, oh, he can't hear us. Anyway, he did it in a bit more of an involved way. But he still basically showcased the usage of the correct concepts. So it's all good, Pranav. What about group 5? What happened there? What's the story of group 5?
Hi, we're group 5. So our challenge was to get all the 2 GIFs on the, or GIFs. I'm not going to start that again. The 2, that word from the COVID-19 pandemic wiki page.
Can you share your screen? Show us.
Yeah, for sure. Who is it? Somebody had a better screen than I did.
No, we can see it properly.
All right, there we go. Cool. So yeah, I'll stop talking now because somebody else is supposed to talk.
Oh, your screen.
Where's Xander? Where does Xander's screen go?
I think Xander's muted, but I can give like a basic overview of the code. Basically, what we wanted to do first is we looked at the inspect code and found that obviously all the images had the HTML tag image. And then for the source name, we looked into the actual GIFs by using the button on the top left of the screen that allowed us to see the code specific for those GIFs. We copied the source name, added a comma between the 2 ones, so we were only getting those 2 images. And then to display it, we copy and pasted the code from a previous Colab notebook given to us by Timur, basically saying that the list of tags is equal to sum, which is what we used above, and then IPython.displayHTML, allowing us to actually see the GIFs that we used.
Awesome.
Go ahead, guys.
Yeah. So how did you guys find that? Was it fun, informative, boring, excruciating? Everyone, anyone.
I think the challenge was pretty fun.
Yeah, I thought it was fun too.
Yeah, I thought it was fun.
Good. That's really good to hear, guys. This is our first challenge, so obviously there are some things. Sorry for the technical difficulties at the beginning, but it's really nice that you guys are able to problem solve, actually. I just want to go over some cool things that I saw. In multiple groups, there was definitely a lot of teaching that was going on, which was very impressive because it just shows that there's different levels, people at different levels of knowledge, and they're able to help other people rise to that same level. So good job on you guys. Also, some people encountered recurring screen sharing issues, and you guys were still able to overcome those challenges simply by communicating your steps and using really good communication essentially. So again, very good job, guys. I think you guys did a terrific job. Don't worry if you didn't get your picture, or you're working through a problem. The idea is to work with a team. I think you guys aced everything, so give yourself a pat on the back for that. Otherwise, we'll give it over to teamwork.
All right. So I hope we have time to get through the lesson today. If we don't, some of the lesson can be given for like homework. It's just basic reading. But let's just get to it. Let's see if we can make it happen. So now that the group activity is done, let's move on to pagination in web scraping. So pagination is scraping multiple web pages from a certain website. For example, scraping multiple pages of Google results, or multiple pages worth of hotel reviews, or multiple pages worth of tweets. Usually this is done by modifying the page URL to switch to different pages, but it also includes scraping links off a given page and then scraping the information that those links lead to. So imagine like scraping a list of links and then each link has a URL. So you scrape each of those URLs and you keep going basically. The goal of this collab is to scrape all the results that come up when you Google your name. So in my case, Timur Kairulan. So what does that look like, right? Here, Timur Kairulan. There's me. There's 7 pages worth of Google results. So we're gonna try and figure out how to go through all 7 pages using the way I described before. So first, we obviously need to import all the libraries. What's this? The first real step is to find a starting URL, often the very first page of what you're scraping, and figure out what component in the URL is responsible for the page number. This is done by comparing the URL of the first page to the URL of the second page, looking for a number that has changed, like 1 to 2, 0 to 1, or 0 to 10. However, sometimes the pattern doesn't appear until the second page, like it is with Google results. After a pattern is found, replace the changing element with %s, which will enable us to put anything we want in %s. Imagine %s being like a placeholder that we replace with different page numbers using our computer code. Oh, that's a mouthful. What does that even look like? I will tell you straight up right now, pagination is less about the actual code part. The actual code part doesn't change much. It's about the problem solving and the puzzle and the puzzle that you set out to solve. So, Timur Kairulan, I have this URL, and it doesn't say much. I can't really tell, like search, question, Chrome, J, source ID, doesn't really tell me much. But what if we go to the second page? What changes? Boom. The URL is way longer, and we can kind of see certain words pop up like start. What does that mean? That's giving me different signals. Maybe we start at one place and it says start equals 10. So maybe that means something. What if we go to the third page and see what that is? Oh, start equals 20. So now we just noticed that start equals 20 is the start value for page 3. Now what if we go to page 4? Start equals 30. We know that there's a pattern now, and we know it has something to do with the number 30, 20, or 0. Now, what if we actually just take that, delete it out of the URL, and put 0 instead? What do we get? Oh, we're back at page 1. All right. So now I think we can scrape through all 7 pages. Let's see how we do that in Google Colab. So we put the start URL with start equals %s, as shown right there, inside of a variable to use it later. Next, we generate a URL for every page we want to scrape using a loop and the replacement technique discussed earlier. This code block is meant to be copy-pasted, but it is a little involved. So you will have to change more than you usually do with my code blocks. So how many pages is there? There are 7 pages, right? So we go to here, there are 7 pages. That's an easy fix. But what is all this nonsense? All this is basically saying is we're looping through a loop the amount of times that there are pages. So say there are 7 pages, we're going to go through the loop 7 times. The only part you really need to change is this little tiny bit right here, which dictates what we replace %s with. Sometimes, for example, on not Google, the page number will, instead of being 0, 10, 20, 30, it'll go 1, 2, 3, 4, or 0, 1, 2, 3, 4. And at that point, you need to be able to take the page number that the computer thinks we're on, say from 0 to 7, and figure out how to change, make that number into the number we want. For example, if we're on page 1, that number needs to be 0. If we're on page 2, that number needs to be 10. In our case, we just do that number times 10, and it works perfectly. So let's see it run. Boom. We just generated all of the URLs that we're gonna scrape now. Am I going too fast? Is everything okay? Yeah?
So that it's just a loop, right? Basically, you're just creating a loop. It'll loop through all the number of pages, right?
Yeah.
Okay.
I just don't want anyone to get too lost is all I'm saying. So next, we will scrape each of the generated URLs for all of the A tags. Remember, what are we looking for? We're looking for the actual search results, right? We're looking for the search results. So we need these links, which are A tags. This is perhaps the most important code block for this concept. Keep that in mind. So we make a list called results, and we have a loop. Now, this part of the loop doesn't matter. It's this part that's very important. So right here, you should see something familiar from last week. You should see soup.findAll. And that's the key function that we use to search for tags on any given web page. And that's what we're doing here. Except here, the soup.findAll is going to find all the tags on each of these blue links, of these blue Google search links. So on each of these blue search links, we're going to find all the A tags, and we're going to put them in results. Now let's do it. Actually, this is probably going to take a while. Oh, there we go. Look at that. Look how many A tags there are. That's 7 pages worth of A tags. But what you'll notice is not all of them are the actual links to websites and everything. Because if you look at the actual Google search, there's things like this images button, which is actually an A tag. You will see that there is the settings button, which is actually an A tag. You will see that the next button is actually an A tag. You will see that this, I think, is also an A tag. Right? So we need to clean our data. This is called data cleaning. This is the last step. And it's the most difficult out of all of them, to be fair. So now that we have all the A tags, some of them are just buttons or previous or next pages, links to advanced search options, not to mention the angle brackets are not removed. We now have to clean our data. This process varies heavily on a case-by-case basis. In the case of Google results, we will need to only take the A tags with an href attribute value that starts with /URL?Q. Now, how do I know that? Well, I just looked at what we actually wanted. So let's see what we actually want. And we'll see that here, there should be, there it is. So the A tag starts with /URL?Q. And let's see if I can find another example. That's a span, that's an H3. There's the A tag. And there it is. /URL?Q ? Or URL?Q. Chat. Hello, Kevin. What's up? So that's what we do. We do some crazy, not crazy. It's just kind of involved data cleaning, and it's not too difficult, but it does require some Python knowledge. So this is the most technically difficult part of working with any data set, not just information from the web. You will find that data cleaning requires a lot of effort and a lot of thinking. In this situation, I kind of tried to comment everything that I'm doing, but what you need to understand is I'm using string manipulation techniques to kind of remove parts of the data that I don't like or don't need, and only keep the parts that I like. And in the end, we get, ta-da, just the links that we want. Isn't that amazing? You can find my LinkedIn here. You can find my dev post. You can find an Amazon link. You can find my YouTube channel, my GitHub, my Tech Under 20 profile, my Instagram profile, and my Twitter. All from these links. So that's Pagination. Any questions?
So this is again in that same drive like last week. So
Yeah,
Google Colab.
yeah.
So like for advice to practice this, we should do like we should take our name and try to find the links with our names on it as an exercise to
Yeah.
practice pagination or.
Yeah, exactly. Exactly. That's
Okay.
exactly what you should do. If you're just going to do that, just make a copy of this document and change a couple of, you shouldn't need to change too much. There's going to be a different number of pages. Obviously, the start URL is going to be different, but it shouldn't be too difficult. For a real challenge, try scraping multiple pages of something like TripAdvisor or something like Yelp for reviews. That would be a challenging one if you need that. What I'm going to say right now is the quote unquote pagination that you will be doing for the actual application of all of this that we're trying to get you to do, which is the COVID business stuff, doesn't include the only really includes this. This code block is extremely important, so you should keep it in mind. But this part and this part are much less needed because all of the links that you're scraping are present on one page, and you can scrape them all at once, and then you have a list of them that you can just go through and get the data from. So yeah, once again, if you're lost, please tell me, please message me, email me, whatever. We want you to succeed. But we also only have what 10 minutes, 15 minutes left essentially.
I have a question.
Yes.
Yes, so for like the data cleaning, is there like always like some commonality with like the links that you're trying to clean out, or do you have to look for that?
You kind of, it's like a puzzle again. So you have to kind of like see how the data is laid out. What are the common attributes? What is different about each data point that you actually want? And in this case, I found that the href value of the href attribute values always starts with /URL $Q. And then I can do some string manipulation in order to get just the links. But yeah, so let's move on. Navigating HTML tables. This one's shorter, I promise. Learning to navigate tables is useful for navigating any information nested within a specific tag. Rather than scrape all the tags on a page, you're scraping a specific tag and then scraping the tag's contents. This document also covers different methods of getting to the data you want when there's no unique ID or class handy. Whew. All right, let's import the libraries once again. Here's an example of a table in HTML. The table tag encloses two main components of the table, t-head and t-body. Both those components enclose table row tags, which finally contain either table heading tags or table data tags. For more information on HTML tables, visit the W3 Schools article. This is once again just amazing. W3 Schools is an amazing resource. It's a godsend 99% of the time. I even use it sometimes when I don't know a tag name. So this article will give a really, really good overview of what a table is in HTML. So here I have inside my little HTML display box an actual piece of HTML that displays a table. This is what it looks like. We see some headings, some items. So how is it structured? Well, see here you see the whole table tag, and then we have the t-head tag and the t-body tag. And then we have the table of rows for each of them. So the t-body has 3 rows, and the table heading only has 1 row. And inside that table row is all the table headings and the table data inside the other 3 rows. That'll give us something that looks like that. But let's look at a working example of a table. Wikipedia to the rescue. List of Walt Disney picture films. Boom. Tables on tables on tables on tables on tables. Gotta love it. What we're interested in this workshop is that all the Walt Disney Pictures films from the 1940s. What we're going to focus on is getting the names and the dates of all the Walt Disney movies from the 1940s. How do we do that? Let's move on. Notice, or to see how tables are scraped, we're going to scrape all the names and dates from the Disney movies of the 1940s. To start, the template from week 1 is used. Remember, this code block, super important. Always use it. This is literally copy and pasted from my week 1 part 2 workshop. Notice that the table for all the 1940s movies doesn't have an ID we can use to find it. So we have to find it in another way. And as we can see, if we go to the 1940s, find the table, it has a class, but it has no ID, which means that if we use the class, we'll get all of the tables in the entire page when we really only want this one. So there has to be a way for us to find just this one. Notice also that right before the table, there's a subtitle. And what do we know subtitles have? We know subtitles have IDs. We can exploit this fact. We are going to exploit the fact that every subtitle on Wikipedia has an ID we can use. Take the find all code block from week 1 and change find all to find. This will look for one tag instead of looking for multiple. Then set up a search command for the span tag with the ID 1940s. So we've seen this before, right? It's just changing the tag name, the class name, and the ID name to find a tag, a specific tag that we're looking for. Instead of .find all, we have .find, so it only finds one tag, which is really important. And if we search for it, there it is. There it is. Where do we go from here, though? After that, we can use the find next feature to find the tag that's immediately after the 1940 subtitle, which just happens to be the table we are looking for. Imagine that. So we put this into the table variable, run it. Let's see what it is. So let's see. Oh, sorry. Boom. We just found the table, just like that. By finding something that we can kind of isolate and identify, and then going immediately after it, we can get the table that way. It should like kind of show you roundabout ways of getting to data. Notice how the names of the movies don't have a class or ID we can use either. However, they are all italicized, so we can use that to isolate them. Once again, we're going to modify a template from week 1, this time changing the tag to the I tag, which stands for italicized, and removing the ID and class search parameters. Make sure to also use table instead of soup. Also, instead of just displaying a result, we're going to put it into a variable called names. So here, once again, we have the find all code block. This time it is find all, it's not just find. Once again, it's been copied from basically week 1 part 2. Let's see what it does. Boom. We have all the names from the 1940s movies. But the tags are still there, and we need the text. Next, we're going to extract the text from the list of tags we just generated using a template from week 1. At the end, we put the text we found into a new variable, names text. This is another code block from week 1, super important, get text. Let's see how it works. Boom, we have what we wanted. Well, half of what we wanted anyway. The names of the movies from the 1940s. To isolate the dates, we once again have no unique attributes or features to cling onto. So we use the .findNext command twice inside a loop to find each date tag. Using the commands once gives the A tags inside the I tags instead of the dates. The dates are stored in the dates list. What the heck does that mean? Let me illustrate it visually. If we look at Pinocchio right here, we see it's an A tag. We see it's an A tag enclosed by an I tag. When you say I tag, when you call dot find next on the I tag, which is what we found, you get the A tag. So once you have the A tag, you can do dot find next again in order to finally get to the date tag. Please tell me if that's unclear, if I need to repeat myself. This is one of those weird.
Timur,
Yes.
why don't you just go next straight from the A tags?
Straight from the A tag?
Yeah.
Because it would require me to find the A tags within the I tags, and the A tags aren't as unique as the I tags.
Okay.
Yeah. So there's more. Obviously, there's more than one way to solve this problem, but this is just the way I like to illustrate it. Also gets you guys used to dot find next. So we use dot find next twice within a list, and what do we get? Boom, dates. And once again, we strip the dates of the tags. We do some tiny string manipulation on the get text code block, and we get, boom, just the dates. And now we have the names and the dates. And that's all extracted from an HTML table. Any questions? We have 5 minutes left. I think we can do this.
I have a small question,
Sure.
Timur. About using the find next. When it's finding the date tags, is it just automatically clinging on to like the next piece of information it sees, or how is it like, did we somewhere write down like what tag we needed to find?
No, it literally finds the next tag in the entire web page.
Okay.
It's quite useful actually.
Okay, thank you.
Any other questions? No? Once again, this is going to be made available. The slide is going to be made available. This is being recorded. So consult those resources if you have any problems. We are going to finally move on to packaging and exporting data. This is extremely short, extremely surface level, but it will get you guys to actually get an Excel sheet from all your efforts in web scraping. Imagine website to Excel without having to copy anything by hand. That's insane. So for this notebook, we're going to use something called Pandas, which is a Python library. Pandas is a Python library used to easily manipulate big amounts of data. In this exercise, we will use data we collected from the last notebook. Throughout this notebook, we will use the Pandas data frame to organize and export data. First, let's import the library and copy the names and dates from the last workshop. We know how to do this. We did this just now. Next, we generate a random rating for each movie and put it into a list called ratings. This is silly, but it's meant to show that how to handle data that's not just words. So given that we don't have ratings for these, I just decided to generate some random ratings. Basically, this isn't really important. It's just to basically get another list of numbers that we can attach to the names and the dates. This is where the next part is where the magic happens. We declare a Pandas data frame, kind of like a spreadsheet that we can manipulate in the following code block, putting in the different column names and connecting them to lists of data that already exists. The format is column name, colon, list. So let's unpack that. Here, as you can see, if I zoom in, we have a DF, which is usually what data frame is. And then inside these curly braces, we put the column name and then the list of data that it represents. And then another column name, and then a list of data that it represents. And then another column name, and then a list of data that it represents. All separated by commas. So that's what's up with the data frame. Let's see how it looks. Bam. Isn't that amazing? That already looks like some sophisticated data that we got from a web page. Next, we sort the values by rating by using the dot sort values command. The following code block can be used to sort by any column. Just replace the rating, in quotes, with any other column name. Let's see what this does. So I use this code block, this line of code. Basically, replace rating with any column name that you want to sort by, and it's going to sort by it. So here we have Make Mine Music, released on April 20th, having a rating of 100%. And then at the bottom, we have Victory Through Air Power at a rating of 25%. So before they were unsorted, and now they're sorted. Ain't that neat? I'm just checking the chat. So finally, we can download our data to a CSV, a comma separated value, also known as an Excel file, to do further analysis or visualization in Excel or Google Sheets, along with MATLAB or even Python. This is done using the toCSV command. This file is retrievable via the folder icon on the left of the screen. What does that mean? So once we run this and click this folder icon, we will see the data.csv comes up, and we can download it. Boom. There's our Excel file. Let's open it in Excel. And there's our table that we scraped. Ain't that neat? So now you can make a graph out of this.
At least
You
I
can do anything.
Can you all see the table?
Yeah, we can't see it.
Excel?
Oh, sorry. Yeah.
Oh, it's because it's Excel. So
Yeah, it's because Excel. Here. There it is.
cool.
So now we can make a graph out of this if there was more data, for example. I think that's super cool already. So moving back here are all the steps in one code block. Literally put this at the very bottom of your notebook to do the entirety of the data formatting and the data formatting and exportation and packaging. That's about it for today's workshop, guys. It was quite packed. I hope you had fun with the group activity. I had fun with it. It was great seeing you guys work together. And once again, these are all available in the workshop materials that I am going to share the link to in the chat. Here it is. Any last questions before we end the workshop?
Yeah, I have a question.
Yep, go for it.
Are you aware that you're running out of Google Drive storage? Like how are you gonna do these workshops in the future?
It's all stored on TU20's drive. It's not my personal one.
Okay, that's great. That's good to hear.
Thanks for spotting that though. I see one question from Moog. Wait, will our groups be announced now? So in terms of choosing your group members, we will be I'm gonna have to clarify that within an email. So to whomever so hopefully everybody signed up on the Tech Under 20 Ventures form because you'll receive an email pretty shortly regarding the group members and then the other form that you need to fill out to confirm your spot in Tech Under 20 Ventures. So there will be a list of tasks that you will need to fill out or complete before next Tuesday. But yeah, we will address that and we'll send you guys an email in a few hours. Good. Are there any other questions? I just want to share one last thing before we go. I won't take too long, or maybe about 1 or 2 minutes. I understand we went a little bit late, but Timo, what do you think? Should I share the plan for this case, or should I just send it in the email?
I think you can display it as long as we don't talk about it for too long. It's fine.
Yeah. Okay. So I'm just gonna go through it real quick then. Give me a second. Okay. Where is this? All right. Okay, well, I guess I can share the screen right now, but essentially, there's a document. You can take a look at it. Give me a second. Yeah, so if you go in, can you guys hear me?
Yeah.
Okay. So if you guys take a look at the document that I sent within Zoom, essentially, that's just a there's just a link to the timelines and expectations for case one. So as you guys know, we already finished week 1, 2, and 3, I believe. Week 1 and 2, sorry. So today was week 2. So you should be, if you can, jump to where I am. So you pretty much worked in groups. So for next week, we're going to determine your group members. We will send more information over, so don't worry about the first task. And let me just remove this for the time being. And then you're going to collect the data off the Government of Canada website. We'll include the link to that as well. As always, if you guys have any difficulties, feel free to ask your fellow chapter members or even reach out to us. Otherwise, you guys are essentially going to be grabbing your data for your solution. We're going to pitch this. We're going to create a specific document with what we're looking for with your recommendation for when you present it in 2 weeks' time, and pretty much what you guys need to include within your presentation, so you guys can pitch effectively. Otherwise, that was just a blanket statement. Anyways, I think that's it for today. We'll send you guys an email after the workshop. Sorry for going over for a bit today, but definitely seemed to be a really action-packed workshop. Cool.
Yeah, let's go.
Was I not supposed to click the link because I think I got to it before you deleted it?
Yeah.
I guess you're real fast then. No, it's all good. There was just something that needs to be clarified on that, so I just wanted to make sure that we didn't get anyone to fill it out before. Yeah, so you're all good, Xander. Don't worry. Anyways, are there any other questions? No? Alrighty, so if you guys have any other questions, feel free to ask on Discord. We're all pretty active on there, as you can tell. And yeah, otherwise, so the weekly workshops again are on Tuesday from 5:30 to 6:30. If you guys have any other questions, concerns, comments, you guys want to talk, Discord's a good place. Otherwise, take care, stay safe, and we'll see you guys next week.
Yeah.
Bye.
Next
Thanks
week
for the
is not going to
awesome
be.
workshop.
Cool
Thank you,
workshop.
guys.
It's really good.
Thank you for this awesome workshop.
Of course.
Next week is not going to be a technical one though. So much.
Yeah.
We'll be meeting here, right?
Yeah.
Yep. Same link.
Okay, thanks.
Yeah. Cool. Alrighty. Take care, guys. I'm gonna end it at that. If you guys have any questions, let us know.
I'm stopping the recording now.
Yeah, the video will be on the Tech Under 20 YouTube.
Mm-hmm.